From a very early point of time, people have asked what light is. Famous Greek philosophers like Plato, Socrates, and Aristotle established the foundation of modern optics. It was not until Isaac Newton when things changed in the research on light. In 1672, he announced that white light is actually composed of various colors, having different refractivity, opposing the very old belief that sunlight is a pure white, as proposed by Aristotle. He also proclaimed that light is like a particle, because the shadows that the light creates is extremely sharp and clear, and that the properties of refraction and reflection can only be explained through particles. He called this the light particle theory. But, as expected, these were opposed by some scientists. Christian Huygens, a notable physicist, argued that light is actually a wave. He published mathematical proofs and concepts in 1690 to prove his point, but unfortunately, the theory was not widely accepted. Centuries later, when the light particle theory is already popular, Thomas Young, a notable British polymath, wanted to prove that the wave theory of light is true. To do so, he needed to create an experiment that proves this hypothesis. And today, we're going to replicate that experiment. The materials we need are simply the following: laser pointer, scissor, electrical tape, very thin cable or wire, and any object to hold the laser pointer. Procedure: cut 2 small strips of electrical tape and place it in both ends of the laser's opening. Cut a short strand of wire and tape it at the front of the opening, parallel to the 2 tape that we put. Again, close the gap between the tape and the wire by adding a few strips of electrical tape near to the wire. Make sure that there is still a very small space in between the wire and the tape, which would leave 2 small slits. So what can we expect when we shine a light between these 2 small slits? We should be able to anticipate 2 parallel light on the surface. How is this possible? Why is there a series of parallel lines that extends in the surface? This very simple experiment by Thomas Young proved this point that the wave theory of light by Christian Huygens is true. In his explanation, light behaves like a wave, as this pattern that we can see can only be produced if photons have wave-like properties. If it behaves like particles, we will simply observe 2 bright spots on the surface. If it is a wave, then the wave produced on the other side can interact with the wave produced by the other. Imagine a series of droplets. From one source, we could only see a circular wave front. What happens when we add another source? We could see that it produces a fascinating pattern. We observe that there is a bright spot and a dark spot. Interestingly, this pattern can be seen from Thomas Young's experiment. The bright spots are formed as the peaks and troughs of both waves collide with each other, and this is what we call constructive interference. On the other hand, dark spots are formed when the peak and trough of both waves cancels out. This is called a destructive interference. When a series of straight light passes on 2 slits, it produces 2 waves that interfere with each other, thus creating this pattern. So as we can see, photons do behave like a wave, and Thomas Young proved this point with a simple experiment. However, the story does not end there, as Einstein later found out in the 20th century that the photoelectric effect can be explained only when using the light-particle theory. Thus, light behaves as both particle and wave. With this simple experiment, we can clearly see that photons have wave-like property. Thank you everyone for watching.